Lesson 12, Units and Scale Drawings. Let's use different scales to describe the same drawing. Our icons are I can tell whether two scales are equivalent, and I can write scales with units as scales without units. So make sure you have today's date, your icons, and you're ready to move on. Oh, don't forget that page number. Let's do a quick bit of warm up into what we're doing. Let's look at centimeters in a mile. So you may not have all of these memorized, but these are certainly ones that are used quite a bit, especially if you get into different levels of science. You're going to really need to know your metric units. They are very easy to convert, but the United States uses customary most of the time for everything, so still need to know your customary lengths and other units besides just lengths. So there are 2 and 5,400 centimeters in an inch, 12 inches in a foot, 5,280 feet in a mile. Which of these would give you the number of centimeters in 1 mile? So to get that mile, we would have to take the number of feet times the number of inches times the number of centimeters in those inches. So B is our best one here to find out how many centimeters are in 1 mile. What does C represent? Yeah, this would actually be going the opposite direction, right? This would be converting centimeters into miles. So it would be like multiplying by the fraction, or you could also think of it as dividing by this total number. The others give you something completely different. D doesn't work because you're talking about adding each of the parts as opposed to multiplying each of the pieces. And you have to multiply because for each one, you've got multiple parts for each of them. Let's jump ahead and talk about the world's largest flag. So Tunisia, this little country here in northern Africa, has a record for the largest version of a country's flag. So it covers almost 4 soccer fields in just its length. Its length is 396 meters. And if you're going to convert that into a scale that would fit on a piece of paper, what do you think the scale would have to be? Well, you could do a ratio without units on it and do something really big. So, there's 100 meters or 100 centimeters per meter. So you could have, let's see, probably 1 centimeter on paper would be like, at least 500 probably 5,000 meters or 5,000 centimeters. Actually, that seems awfully small considering this is almost 30 and that's almost 400,000 when you convert it. So you're probably talking about like 15 to 20,000, 1 to 15,000 scale, but that would be converting the meters into centimeters. Remember that if we don't say the units, that they're in the same units scale-wise. All right, so let's think about this right here. And this is a conversion to help us convert between the two measurements. So they're saying with this that it is a 1 to 2,000 scale. What do we know automatically about this? Yeah, that whatever units it says here is the units that they're using with the 2,000. So if this is 1 centimeter, then this has to be 2,000 centimeters. So how do we go to fill in these parts? What do we have to do to go from the flag's length to what it is on the scale? Well, you have to get these first into centimeters. So how many centimeters are in a meter? Yeah, 100. So we have to multiply that by 100. So we end up with 39,600 centimeters. And then on our scale drawing, it's 2,000 centimeters for every 1 centimeter. So then our next step is, we have to divide this by 2,000. Okay, so we'll go in there. Let's see, 9 times. That'll get us at least close to it. Eight, yeah, 8 would give us the 16,000 that we need there. All right, so in the scale drawing, it's 19 8/10 centimeters. What about here? Okay, again, you take the number of meters times 100 to convert it into centimeters, and then you divide by 2,000. And that'll go 4 times here. $2,000 go into 19,000, 9 times. And comes down again. It's going to go 5. That'll give us 10,000 to get rid of that. Oops, I did something wrong. I know what I did wrong. I have the right digits. But what did I do wrong? Yeah, it was a place value problem. 99 times 100 is 9,900, not 99,000. So it should be 4 95/100 centimeters, which makes sense. The way I had it, it was going to be much larger. So fortunately, this works out just fine to be the correct size with it. What about here? We're actually going to do something different, aren't we? So now we got to do the opposite process, right? So we have to multiply by 2,000 this time. Which gives us 264,000. Oops, nope. I forgot the place value again. Dag blast it. Yeah, because when you multiply that out, you're going to still have tenths, so I needed tenths there. So it should really be 26,400. And then you have to divide by 100 to get it up here, which is 264 meters. That's a pretty large flag. But again, since we didn't have the label here, we had to use the label that we had within the heights that we already, or the distances we had in the scale drawing to help us figure out what the actual was. Just remember the scale does not have to be in terms of one scaled unit to something, but one is usually chosen because it's the easiest scale factor to see and make calculations even faster. I know most of the time we use digital maps anymore to go places, but even on those, you'll see that the scale on those is typically going to be 1 inch or 1 centimeter equals however many miles in real life. So it's not always necessary, but it does typically happen that way. So how can we express 1 inch, a scale of 1 inch to 5 miles without units? Yeah, you've got to take 12 inches in a foot times 5,280 feet in a mile. So you could say that it would be a 1 to 63,360 scale. And then that would equal 1 inch being 5 miles. A scale tells us distance on a scale drawing, how that relates to the actual distance. And it also can kind of give you an idea of the area on a drawing, how that corresponds to an actual drawing. So if a map has a scale of 1 inch to 5 miles, how can you find the actual area represented on the map? Well, to find area, it's length times width, right? And if on the map that you drew, it's 1 inch by 1 inch, that's 1 square inch. Each of those inches represents 5 miles. So you take 25 times however much the area you have on the paper is. And why is it 25? Because each of those inches that make up the sides are 5 times 5, because it's 5 miles for each of those inches. And so you get 25 square miles in each square inch of the map. How can we find the region's scaled area if we know the actual area? In other words, if we know the actual square miles of an area, how could we convert it using knowing that our scale is 1 inch to 5 miles? Well, we multiply by 25 from the scale to go up to what it is in real life. We would have to multiply that area of the actual region by 1/25. Remember that that would be the same as dividing by 25. And oftentimes now you're going to see more often in the type of math that we start getting into, you're going to see instead of talking about division, you're going to talk about it as multiplying by the reciprocal fraction. Okay, so that is it for today. Thanks for watching.